Math 3, Unit 8, Section 2. Today we're talking about angles in standard position, and we're going to talk about solving for an angle. So, standard position, you guys can read these huge definitions if you want to. The main thing is that you always will start on your initial side, which is right here, okay? And then when you're finding the angle, you go like this, and then you'll state what your angle is, okay? So you're kind of showing the measurement of your angle. One thing we were talking about prior to recording here is that this, again, we're talking about our unit circle, and so we know that all circles have how many degrees? 360, okay? And if we were to cut this into fourths, starting here, this would be 0 degrees, and then a fourth of a circle is 90. Then you get to 180, 270, and when you get back up, this ends up at 360. When you have a positive angle, positive angles always go counterclockwise. So this is showing a positive angle. You start at your initial side and you're going left. Okay, so if you want to, you can say, you know, starting here and you're going left or up. Negative angles, though, will go... They go clockwise, or I think of it as down. I mean, you could think of it however you want to, but you'd be at the initial side and then going down. Does that make sense? I'm going to show you what I mean. You'd be curving down, where on this one, you're starting here and going this direction. Okay, reference angles are the big idea today, okay? Couple things about reference angles. First thing is that your answer for the reference angle will always be less than 90 degrees. Okay, the next thing is that they always go to the x-axis. So if you're looking right here, this angle they've drawn is 60 degrees. Okay, that's 60 degrees. The reference angle for this one, it always goes down to the x-axis. And in this case, the reference angle is also 60 degrees. Okay? This angle right here, they're telling you it is 120 degrees. So they start here, this is a 120 degree angle, okay? The reference angle always goes down to the x-axis, and you're trying to find this missing piece. That missing piece right there is your reference angle. And so since we know this is 180, that missing portion right there is 60, okay? Here, this angle right here they've drawn is 240 degrees. So 240 would be in the third quadrant. And this reference angle right here, again, you always go up to the x-axis. This piece, if this is 180, down here is 240. So from 240 to 180, that missing piece right there is 60. Okay, and this last one, they drew this angle as 315 degrees. Again, it always goes up to the x-axis. And so if this right here is 315 degrees, this angle that's missing, if you take 360 minus 315, you are left with 45. Okay, the other thing you need to remember is your quadrants. So remember that this is quadrant 1, 2, 3, and 4. And then we're going to go ahead and practice this. Okay, and we might not do all of these examples. We'll see how it goes. So I'm just going to write this out one more time. Remember, this is 0, 90, 180, and 270 degrees. And then this goes back up here at 360 degrees. So on problem 1 here, or on this first example, they want us to sketch the angle in standard position, identify the quadrant, and find the reference angle. Okay? So 170 degrees. What quadrant would that end up in? Okay, so how you draw it is we start at the initial side right here, and it would curve around into quadrant 2. And then you draw the ray right there. And I normally just mark it right here as 170 degrees. So we've done part A. We've sketched it. You also told me already that this was in quadrant 2. To find the reference angle, all we're going to do is we always go down to the x-axis, okay? And we have to find this piece. If I know this is 180 and I'm stopping at 170, what is that missing piece? 10. That's it. 10 degrees. And one way of finding that would just be 180 minus 170. Okay. Next one, 210. What quadrant will we end up in? Quadrant 3. Good. So we start at the initial side, we go around, we draw this right here. We're going to label it as 210 degrees. This is in quadrant 3. And we always go where to find a reference angle? We're always going up to the x-axis. So this 210 is going up to 180. And so what would be my reference angle right here? 30. Pretty easy, yes, no? So, and if you need to do it mathematically, you would just take 210 minus 180, and you would get 30. That's where the 30 came from. Okay, 320. What quadrant will it be in? So this goes around, it ends in quadrant 4. We draw the terminating ray. We label this as 320 degrees. You already stated it's in quadrant 4. Your reference angle always goes to the x-axis. We're trying to find this missing piece. So this time it went up to the line here, which is 360 degrees. So what would it take to get from 320 to 360? 40. That's our reference angle. Yes?
Okay, so like on the second one that you did,
Mm-hmm.
how come it can't go, because you know how the middle line right there would be 270?
Mm-hmm.
Why can't it go to that one?
So reference angles are always, yeah, it's always going up to the x-axis. So you're always looking from this line where, how much is it between that and the x-axis? Okay? All right, 70 degrees. Where is that? What quadrant? Quadrant 1. We're just going to label this as, sorry, it goes to 70 degrees. Your reference angle always goes to the x-axis, which means it's going to be what? 70. Okay, so the reference angle and the actual angle ended up being the same here in quadrant 1. Okay, negative 70. What am I going to do for negative 70? It's going to go down. So instead of going up and around, it's going down. And it's going to be in what quadrant? 4. So it's going down. We draw our terminating ray. You're going to label that as negative 70 degrees. The reference angle will always go up to the x-axis. Good. We already said it's in quadrant 4. What's that reference angle? So reference angles are always positive as well. I forgot to say that. So it's 70 degrees. Okay, next one, negative 100. Where is that going to go? Which quadrant?
3.
Very good. So it starts here at our initial side, but it's going down. It's going to end here in quadrant 3. We're going to go ahead and label this. This is negative 100. This right here is 180. How many degrees does it take to get here? 80. And it's in quadrant 3. Okay, what would we do with 620? Yeah, it's just going to wrap around. And so we know when we go around one time, that's 360. And so I'm going to take 620, and I'm going to subtract 360 to see what's left. and you end up getting 260. So which quadrant will that end up in then? The third. So notice what I did. I did one whole loop around, which made 360, and then I have to go another 260, and I'll end in quadrant 3. Okay, and I draw my terminating ray. You also still want to label this as 620 degrees. Okay? But this is going to go up to the reference angle. Now we know the reference angle is always what? It's always going to be less than 90 and always to the x-axis. And so we're just trying to find this piece. Well, we know that this, even though we have 620 here, it really is at 260. And so what would it take from 260 to get up to that 180 line? Wait.
No, 80.
80. And again, you could find that by going 260 minus 180. Okay? All right, this last one here, negative 300. So again, we started our initial side. We're going negative 300. So this is negative 90. This is negative 180. This is negative 270. And negative 300 would end up being in quadrant 1. Now, what will this reference angle be? Very good. Okay, any questions before we move on? Okay. Okay, this next part, we're going to find the missing coordinate for the point on this unit circle. Okay, then we'll find the simplified sine, cosine, and tangent ratios for the reference angle. Okay. So what they have told us here, and we know that this goes x and then y, they're saying the x value is negative 4/5. Well, what that actually represents is that this right here is negative 4/5. Is everybody good with that? Okay. If this is 1, but I have this right here as a fraction, I want to change the 1 to be a fraction with a common denominator. So what would I change 1 to be? Okay, we're going to change 1 to be 5/5. Okay? So what we're missing is we are missing this length right here. If this right here, if this denominator is 5 and this denominator is 5, this denominator over here is also going to be 5. Okay? And we're finding the length right now for the y. And so that means for sure I know for the y, the denominator is going to be 5. How can I find what that numerator value will be? How can I find that value? Exactly, your Pythagorean theorem. A squared plus b squared equals c squared. The only one we have to make sure we know is our c squared. And what is our c squared? 5. We're just going to use our numerator values. And so for our c squared, our c value is 5 squared. And then a and b don't matter, so I'm just going to write a squared plus negative 4 squared equals 5 squared. We go ahead and simplify. We get a squared plus 16 equals 25. We subtract 16 to both sides. We have a squared equals 9, and the square root would give me a equals 3. Now, you could have done a squared plus b squared equals c squared with the fractions, but that's not as fun because this is way more fun. And so anyways, just so you know, I could show you how that works out if you want to see that later. So what is my missing y value? Okay, 3/5. Now, there is a long way and there is a short way for telling you how to find these sine functions. Okay, I'm going to show you the short way. And then I will explain the long way if you want to know it. Okay? The first thing that, and this might be another index card we want to make, but sine is always equal to your y value. Cosine is always equal to your x value. Okay? I also remember this, x comes before y, and c comes before s. So that's how I remember cosine and then sine. And then tangent is always y over x. Okay, so based on all that information, what is my value for sine of theta here? What's my y value? 3/5. Okay, what is my cosine value? -4/5. Now the tangent is the one that gets a little bit more complicated. I'm going to write it over here to the side. My y value is 3/5 divided by my cosine, which is -4/5. And how do we do a fraction divided by a fraction? Yep. Yeah. Or you can do keep, flip, change, right? Keep the 3/5 the same. We're changing this division into multiplication, and then you have to flip that fraction, and so it's going to be, and don't forget your negative, and then I'm just going to cross that out. What happens with the 5s? Cancel out, and we just end up with 3 over -4. So tangent is -3/4. The long way, you know how it's like opposite over hypotenuse for sine? So opposite of theta is 3/5 divided by 5/5 is really 3/5 divided by 1, which is just 3/5. And I'm thinking that maybe you guys don't really care. So, all right, are we good to move on? Okay, so we're going to do this one the same way. If we had time, I would want you to do this on your own. Since time is not on our side today, we're going to do it together. Always label your ordered pairs with x and y so that you don't forget. You could also label them with sine and cosine. Okay, and so x again represents cosine and y represents sine. Okay, now since this is my y value, on this figure, that is your y. The y is the up and down. And so I'm going to label that there as -5 over 13. And again, notice how this is going down, which is why it's a negative. Okay? Since this is 5 over 13, what do I want to change my hypotenuse of 1 to? 13 over 13 is correct. Okay? Which means my x is going to have what as a denominator? 13. And then how do I find the numerator? Very good. A squared plus b squared equals c squared. Okay? And so what is my c value? 13. So I'm going to write this as a squared plus -5 squared equals 13 squared. A squared plus 25 equals 169. We subtract 25 to both sides. And we have a squared equals 144. Very good. And a equals 12 when we take the square root of both sides. So that means, what is my x value? Okay, can you go ahead and write in the fractions real quick for sine, cosine, and tangent? Yeah, they're always up here if you ever need them. Do you have the homework packet?
What?
Do you have the homework?
Yeah.
All right, so what's sine? Good, -5 over 13. Cosine? 12 over 13. And tangent? Negative 5 over 12. Okay, do we need to talk through that?
No.
We're okay?
Yeah.
Yes.
So instead of doing the work for the tangent, couldn't you just take the 5 and just put it over the 12 because it's going to cancel out anyway?
Yes.
Okay.
All right. Okay, this next part says fill in the missing sides for the special right triangles found below, then find the acute angle of theta that satisfies the following equations. Okay, so on your 30, 60, 90 triangle, you guys have your cards that we made the other day. What value is across from the 30 degrees? 1. Okay, remember this? Get your cards out if you need to. Okay, across from the 30 degrees, so you have to look at your degrees. Across from 30 is 1. Okay, now across from the 90 on this angle is where my 2 is. And then across from the 60 is my 1 root 3. Very good. We just wrote this in a different way. Again, you have a 30, 60, 90 triangle here as well. Across from my 30 is 1. Across from 60 is, across from 90 is 2. And 60 is 1 root 3. And then last right here we have our 45, 45, 90. Okay, what is on each of the 45 sides? 1. And then across from the 90 is root 2. Okay, so the question here, okay, is what degree gives you 1/2? Okay, is it 30? Is it 60? Is it 45? What does that? So remember that sine is opposite over hypotenuse. So which triangle has one of the sides is 1 and the hypotenuse of 2?
It would be the 1.
Or the triangle.
Wait, no, is it what we did like with this? Where it was like that or something?
Yeah.
Okay.
So we're trying to find the angle though. And so if you look right here, do you see on this angle, and I'm going to highlight now, but I wouldn't highlight on yours because you're going to use them. Do you see how this has a 1 and a 2? Our 45, 45 triangle, it has a 1 and a root 2. Do you see the difference? Okay, so opposite, there's 1, hypotenuse is 2. So what would be the angle that is missing? 30. So this is 30 degrees. Okay. This next one is, because it has a root 2, you know it's coming from the 45, 45, 90 triangle. Okay? But they rationalize the denominator. Because if you look here for cosine of theta, cosine is adjacent over hypotenuse. And this has a hypotenuse of 2, but there's no root 2 in it. And so what happens is, if you look at this triangle here for just a minute, if we were doing at 45, if you had 1 over root 2, how would you rationalize that? Yeah, you'd multiply the top and the bottom by root 2, and you'd end up getting root 2 over 2. And so 45 degrees is correct. They just had rationalized the denominator to get to that point. Okay, which one is tangent? Now remember, tangent is opposite over adjacent. So which angle would that be?
60.
Good. 60 degrees is correct. If you look here at 60 degrees, see here how opposite is root 3, and then adjacent is 1. Okay, and then this last one, root 3 over 3. This one also, when you have a root on the top, there's a really good chance here that it was rationalized possibly. Especially because, do any of these have like a plain 3 in them? No, this one has a root 3, but it doesn't have a 3 number. Does that make sense what I'm saying? So If I were to multiply the top and the bottom here by root 3 to like unrationalize it, this would make what? 3. And on the bottom, I would have 3 root 3. And then what happens with the 3's? They cancel out, and we have 1 over root 3. And this is your, what? 30 degrees is correct. And so if you look here at 30, you can see that opposite is 1 and adjacent is root 3. Okay, do we have any questions?